Okay, this is the last section of Algebra 2, Semester 1, Unit 3. It's section 4.6. We're looking at complex numbers today. So let's talk about what we did last time. We were solving quadratics, so what would happen if we did this? We'd have to divide by -4, correct? Divide by -4. We'd end up with x squared equals -9. Well, now we take the square root to get rid of that squared sign, and we have x equals plus or minus square root -9. Do we have any numbers that can multiply by themselves and get a negative number? We know that 9 breaks down to 3 and 3, but then it's got this -1 in here. That's all inside of the prison. Well, there's a special deal with radical -1. It comes up and we need to be able to clear that radical. We need to be able to show that we're in an imaginary number. When we have x squared equals -1, there is no real number solutions because the square of any real number will never be a negative. Therefore, mathematicians created an expanded system of numbers called imaginary numbers. I stands for an imaginary unit, which is radical -1. If we see I squared equals -1. Okay? So to answer this using the imaginary numbers, we would write x equals, bring your 3's out, and bring your -1 radical out, so it would become I. So x equals 3i. It's an imaginary number. Let's do a few of these. X squared equals radical 13. So we'd square root each side and we'd get x equals plus or minus radical -13. Well, 13 is prime, so it can't come out, but that negative needs to. So we have x equals plus or minus I radical 13. Feel free to turn off the tape and try these on your own without me, and then turn it back on and check and see if it is correct. Make sure to check your answers. So we have x squared equals -38. We take a square root of each side. We get x equals radical -1 times 38 would be 2 times 19. Radical -1 can come out of the radicals, so that would be plus or minus I. The 2 and 19 can't come out, so we just leave them multiplied together. Right here, we have one more equation. We add 8 to each side. X squared equals that would be -28. So we take the square root of each side. That'll cancel out that square, and we have x equals radical 28 is 2 times 2 times 7 times -1. We bring the -1 out front, so it's a plus or minus. We have the I. 2 will also come out, write the 2 in front of the I, and then leave the radical 7 in. So plus or minus 2i radical 7. Okay, next problem. We add 7 to each side. We get a -24 equals 3x squared. Divide each side by 3. We get x squared equals -8. -8, when we do the radical, will be equal to -1 times 2 times 2 times 2. 2 of the 2's can come out, and the -1 comes out as an I. So we have x equals plus or minus 2I radical 2. Okay. Please feel free to pause the tape and do these slowly on your paper and then check what I've got. Now, adding and subtracting complex numbers, we simply add like terms. So 8 plus 5 would be 13. 4I plus a negative I would be 3I. Same skill that we used when we added like terms in Algebra 1 with the x's or y's. So now here we're subtracting. Distribute that negative 1 through the second binomial. So we have 7 minus 6I. Negative 1 times 3 is negative 3. Negative 1 times negative 6I is a positive 6I. So we combine our like terms. 7 minus 3 is 4. Negative 6I plus 6I is 0. So we just have 4. That's a real number. So these others have been complex numbers or imaginary numbers. And we'll talk about those specifics here in a little bit. This one, go ahead and do these two with the tape turned off and then see if you have it right. Negative 1 distributed. Negative 6 minus 7I plus 4I. We combine our like term. Negative 7I plus 4I is negative 3I minus 6. The next one, we have positive 9 plus negative 6 would be positive 3. Negative I plus 7I would be a positive 6I. Okay, we multiply complex numbers. 4I times negative 6 is negative 24I. 4I times I would be plus 4I squared. Now if you remember back from the first page, I squared is equal to negative 1. Anytime you have an I squared, you need to mark it out and replace it with negative 1. So that is negative 24I, and 4 times negative 1 would be a negative 4, and we write our real numbers to the front in our complex numbers. And the next one, we're going to FOIL, or you can do the box. Our first term, 9 times negative 4 is negative 36. Our outside, 9 times 7I is positive 63I. Our inside, negative 4 times negative 2, I would be a positive 8I. And our last, negative 2I times positive 7I, would be a negative 14I squared. I squared gets replaced as negative 1, and we write it out to the front. So negative 14 times negative 1 would be a positive 14 minus 36. And now we can combine these two. 63 and 8 would be 71I. 14 minus 36 would be negative 22 plus 71I. The next one, we distribute. I times 9 is 9I. I times negative I is negative I squared. I squared, it means negative 1. Negative 1 times negative is a positive 1 plus 9I. Okay, this one we're going to FOIL on. This time I'll show you with the box method, in case that's what you prefer to use. I would write, it doesn't matter which one, but I just write 5 and negative I, 3 and positive I. 3 times 5 is 15. 3 times negative I is negative 3I. 5 times positive I is 5I. I times negative I is negative I squared. Combine our like terms. We get 15. 5i minus 3i is 2i minus I squared. Now, we said replace I squared with -1. So 15 and -1 would be 16 plus 2i. Final answer. Next problem, dividing. We want to make sure and use our conjugate idea again. 1 minus 4i, the conjugate would be 1 plus 4i. 1 plus 4i. So now when we FOIL those, we get rid of our imaginary number because we have 1 minus 4i, we have 1 plus 4i, 1 times 1 is 1, 1 times -4i is -4i, 1 times positive 4i is plus 4i, so see those two cancel each other. Positive 4i and a negative 4i is a negative 16i squared. So we have 1 minus 16 times -1, because I squared is -1. Negative 16 times -1 is positive 16, so 1 plus 16 is 17. That's how we got rid of our radical on the bottom, or the I on the bottom. Now up on top, we have 7 plus 5i. We'll FOIL this one. 1 plus 4i. You could do the box if you wanted. Our first is 7 times 1 is 7. Our outside, 7 times 4i, is 28i. Our inside, 1 times 5i, is 5i. And our last, 5 times 4, is 20i squared. I squared gets marked out as -1. So we have 20 times -1 we bring to the front. It's -20 plus 7. We can go ahead and combine. 28i and 5i makes 33i. -20 plus 7 is -14 plus 33i. Now, when you go to write them above your denominator, we always ask that you separate them in case you can reduce either one. So we have -14 over 17 plus 33i over 17. That's your final answer. Okay, next one. 1 plus I is on the bottom, so we want to do a conjugate. It's the exact same numbers with the opposite sign in the middle. 1 minus I. 1 times 1 is 1, and then I times -I will be -I squared, which is replaced by -1. So 1 plus 1 is 2. So on the bottom we have 2. 5 times 1 is 5. 5 times -I is -5i. Okay. Next one. The conjugate would be 5 plus I. So the first, 5 times 5 is 25. I times I is -I squared. That gets replaced by -1. And we can say 25 minus a -1. Negative makes positive, so that's 26. Now up on the top, we need to FOIL that. We know 26 will be our bottom number, but we need to FOIL that 3 plus 4i times 5 plus I. 3 times 5 is 15. 3 times I is 3i. 4i times 5 is 20i. And then our last term is 4i times I would be 4i squared. I squared becomes negative 1. 4 times negative 1 is negative 4. So that becomes 11 in the front. 3i plus 20i is 23i. So we write these above the 26. We have 11 plus 23i over 26. Okay. The next problem, 1 minus 4i, but 1 plus 4i, 1 plus 4i. Again, because we wipe out our middle term, we can just look at our first and our last term. 1 times 1 is 1 squared, or 1. Negative 4 times positive 4 is a negative 16. I times I is I squared. That wipes out to be negative 1. Negative 1 times negative 16 is positive 16. Plus 1 is 17. Okay, now we FOIL our top. 7 plus 5i. And 1 plus 4i. And I just noticed this problem is identical to number 1. We don't need to go any further. We've already worked that one. Okay. Next thing we're going to do is plot complex numbers on a graph. All that you need to remember, this is your imaginary axis, this is your real axis, this is your real number, and this is your imaginary number. It's just like your coordinate grids before. So 3 would be on the x-axis. We come over to 3, and then it's a negative 2i. So we come down, negative 2i. And then go ahead and label 3 minus 2i. On your test, it's required that you label the points. If you don't, I can't tell which ones you're graphing where. Our real number is negative 2. Our imaginary number is positive 4i. So negative 2 plus 4i. Go ahead and turn off the video and plot these, and then I'll show you what my answers are. 3i would just be on the y-axis. Negative 4i, negative 4, negative 3i is right there. Negative 4 minus 3i. Positive 4 minus I. Positive 4 minus I. Negative 3 minus 4i. And 2 positive 5i. That's where they all go. Okay? The absolute value of any number is the distance that number is from 0. That's what it always means. Okay? So let's see what the formula would be. Label the point's coordinates as A, B, I. How can we find the distance from the origin? Well, this point would be 3 plus 5i. Now the distance from the origin is that far. We just need to have a number for that. If you remember from geometry, Pythagorean's theorem, we can find that distance by taking this side squared, adding it to that side squared, and we would have that side squared. Problem is, we don't want that side squared. We want it just the actual distance. So to find that actual distance, we have to take the square root of one side plus the other side. Now, these one side and the other side are the legs of the triangle. If you look at that, it means your real number, which since we label these, a is our real number, so it's a squared. And then it's the b value in the imaginary number, so it's a plus b squared with the square root. We usually label this for the absolute value of a complex number as absolute value z. And it's equal to a squared plus b squared. So here's my a value, there's my b value. I simply take 3 squared plus 2 squared. 3 squared is 9 plus 2 squared is 4, so that's 13. Radical 13. There's my absolute value. A squared, 2 squared, b squared, 4 squared. So that's 4 plus 8, no, plus 16, I'm sorry. 16 plus 4, that would be radical 20. Now, radical 20 can break down so that we get 2 times 2 times 5. We get the 2's out and we get 2 radical 5. That's our absolute value. Here we don't have any reals, so we simply have 0 squared plus 3 squared. Well, 3 squared would be 9. Square root of 9 is 3. If you think about it, that 3i is straight up on the axis. So it really is 3 units from 0. Here we have negative 4 minus 3i. So our a value, 4 squared plus b value, 3 squared. 16 plus 9 equals square root of 25, so this one equals 5 units. Okay. Go ahead and turn off the video and see if you get the same answers here. There you go. And that is the end of that lesson. We'll see you tomorrow in class. Thank you.